So welcome everyone. I'm super excited to talk today about my favorite subject, code-based design. And I'm going to show you a lot of cool stuff, hopefully cool stuff today. Some of the things that we have not presented in public, so completely new things. Okay, so as Nomi mentioned, I'm Marcin. I'm the UXPin co-founder and CEO. I'm a coding designer. I love both equally, code and design. I'm a former design executive. And by education, I'm a psychologist and philosopher. And maybe some other time I'm going to tell you how that influenced my design career and why this is still very, very important to me. But today, we are going to talk about code-based design. Before we'll get into the world of paradigms, I'm going to tell you all about history of design tools. We'll take the path down the memory lane and we'll talk about the origins of design tools and how those origins still influence the design tool markets today. Then we are going to dive deep into the comparison of image-based design tools and code-based design tools. And finally, I'm going to show you a lot of examples of how code-based design tools can actually empower our workflow today and where this workflow is going in the near future. So I'm super excited. Let's start with a little bit of a history. So I'm actually very proud that I found some of the screenshots of the very early design tools. And design tools history really starts back in the 1970s when Xerox PARC worked on the operating system called the Star. And that was the first WYSIWYG operating system out there, the first WYSIWYG interface. One of the first pieces of software that Xerox PARC built for the Star was actually a design tool. And plenty of patterns that this tool started with informed the future of design tools. But the first massively popular design tool out there was Apple Mac Paint, launched in 1984 with the first Macintosh. And it's quite fascinating that you can actually see the patterns when it comes to the tool set, all the little features, and also the interface that we still see in design tools today. You have all the selection of shapes, patterns, the stroke selection, different selection tools for objects. It kind of looks like modern design tools, but with a little bit of a different design language. So Mac Paint quickly took market by the storm, opened up minds of the people all around the world to the creative powers that computers can bring to our lives. People started to use Mac Paint for all sorts of applications. What followed was actually very interesting because a couple of years later, in 1986, a company called Aldus, which I don't think exists anymore, launched a tool called PageMaker. And PageMaker was a desktop publishing tool which used many of similar patterns to Mac Paint, but was meant to actually support designers working on print. And Aldus became very popular. And soon after the launch, it was actually acquired by Adobe and became Adobe PageMaker, which for many decades was part of the Creative Suite. I think it got canceled back in maybe 2006 or so. Another tool, Quark Express, and you can see the similarities across those tools. Another tool meant for drawing illustrations and preparing assets for print was launched in 1988. Now this tool definitely took market by the storm, and in the early 90s allegedly had up to 90% of the entire market of design tools. So it was widely popular for many years to come. It actually still exists, although of course it lost its popularity from the early 90s. Let's move forward, 1987, and you can definitely see the similarities of those tools across the market back in the 80s, but also the similarities of the tools today. So Illustrator, of course, progressed a lot since 1987 when it comes to functionality, but the basic value of drawing illustrations with vectors, the basic tool set, did not change since the launch. And what followed in Adobe was, of course, Photoshop, launched in 1988. And Photoshop looks pretty much the same today, of course. But the most interesting thing that I found about the original launch of Photoshop was this announcement, press announcement. And we'll zoom in so you don't have to read that. Because Photoshop was announced to the market as an image enhancement program. You can see that the value that Photoshop's supposed to provide was actually retouching and editing photographs before further use. That was the original use case for Photoshop. And final tool that became very, very popular in the late 80s and throughout 90s was, of course, CorelDRAW, which was launched as the most advanced illustration tool out there. Very similar to Illustrator, supposedly better. Now, I found this fascinating first little brochure about CorelDRAW just after they launched. And you can see a couple of interesting things. I showed it to a bunch of my friends, and they were all just paying attention to the different fonts used in the CorelDRAW header. The reason for that is that among all these tools that I just showed you, one of the most important thing was actually the font support, the typography, because those tools were meant to actually prepare this asset for the further, let's say, development. And Corel came together with a bunch of really cool typography tools, so that was an important thing. But the most important thing in the context of our entire talk is the header, or the subheader, which calls this package an illustration package. So CorelDRAW was an illustration package. So throughout the 80s, a bunch of tools that survived decades were actually meant to support certain class of use cases. It's either illustration, photographs, or preparation for print in terms of desktop publishing tools. Now, the fact that they were meant to print, of course, influenced the feature set. So the crispy typography was very important. The ability to place objects that are going to look very accurate in print. All of that was crucial for the success of those tools. Interesting thing is that if you compare those early design tools to the situation today, there's a drastic difference that Tweety really pointed out well in his article. The difference is that designers working on print materials and photographs were always working on the final product. So whatever they designed in their tool was the thing that was actually being produced. There was no translation needed. They had a great sense of materials that they supposed to use. They knew how certain things will appear in print. They knew all about colors that they can and cannot use in print. The glossiness of paper, all of that was under their control, and they used those tools to actually produce accurate effects. And that worked very, very well for print design, and it's most likely it still does work very well for print designers. But soon after the emergence of those tools, the situation in the design world changed dramatically, because in the mid-90s, the web became the dominant task, the dominant job of designers all over the world. And almost overnight, print designers started to switch to work on web design. That was a mass movement. And web was not really ready for any design work. So this is a website from 1996. So you can see there's plenty of images. Now, the thing is that CSS was launched on December 1st, 1996. So this is a pre-CSS website, but it's visually very attractive. Now, HTML, of course, carried certain opportunities to style elements, but it was rather limited. I mean, like the task of HTML was to provide a structure for a text document, not necessarily to style it. But this website is actually quite rich when it comes to visual values. So how people achieved that? They achieved it by using assets from all these old print design tools that they would basically place as a background of HTML elements. And this use case actually did not end in 1996 with the emergence of CSS, because CSS really needed another 10 years to mature enough to eliminate a lot of those images and create a code-first environment for user interface design. And that was a fascinating change, of course. The reason for that change is, first of all, accessibility. On this particular website, even the headers are actually images, because there was no way to style text with in such a rich way. So those websites were absolutely inaccessible. Another thing is performance. If you have to download a bunch of images over your internet connection, it's going to be a terribly slow experience. So there are good reasons to ditch all those images. But the tools kind of survive. Today, if you look at any website, the only parts of this website or any digital product that will be images or will be originating from image tools, such as say Photoshop or Sketch, are going to be icons, photographs, and illustrations. So the original use case still exists. Now, the rest of the web is definitely code first. And we today, with all the progress that web technologies made over the past 20 years, we can control the user interface through code and create performant, accessible websites. Now, here's the problem. In the design world, this old paradigm and those old tools survived over the past 40 years. And despite the fact that we don't really need any other assets but illustrations, photographs, and icons from those tools, they're still used to design the entire interface. And this is causing a lot of troubles. Collectively, we are talking about these tools as image-based design tools, because the paradigm is that whenever somebody draws anything on screens, it doesn't matter whether that's Quark Express, Photoshop, Sketch, basically the rendering engine creates either a vector graphic or a raster graphic. So, so tools like CorelDRAW or Illustrator or Sketch today are vector-based design tools, while original Mac Paint was producing bitmaps, so raster graphics, and of course Photoshop is a good example of a raster tool. But the paradigm is really the same. Whenever a designer draws something, it produces an image. Now this is introducing, of course, a lot of problems that we are going to discuss. But before we'll get there, we have to kind of like understand what's going on the market right now. Because you probably don't hear a lot about Quark Express. You're probably hearing less and less about Photoshop over the past year in terms of interface design. But there are new tools which are direct descendants of those old tools. So Sketch, Adobe XD, Figma, InVision Studio, and many other tools are direct descendants of the tools that were actually created back in the 80s. They all live collectively within the same paradigm. And they still serve the use cases of illustration, photo editing, some of them, and of course, icon production. And those tools are very good in these three limited use cases. But when it comes to applying those tools to interface design, there's a bunch of serious problems that are rooted in the paradigm. So they're not something that they can overcome. It's just the nature of these tools rooted back in the origins of print design and the first digital creative tools that were born in the 80s. So the first problem that is probably the most important problem here is that fidelity of image-based design tools is unrealistic. Now, what does it mean? Because of the very nature of the rendering engine that those tools use, they produce the perfect image, the perfect representation of design intent, the crisp text, the highly vivid colors. And that's cool. And if you think about the origins of those tools, that makes a lot of sense because they were meant to serve mostly print, right? The problem is that web, mobile technologies don't use the same rendering engine and have other priorities. And because of that, your text, your shadows, your gradients will look at times dramatically different in your image-based design tools, and then after the development process for web, iOS, Android, for any platform, really. I highly recommend checking out this article listed below, why your app looks better in Sketch. It shows that there's a massive difference in gradients and shadows and text rendering between Sketch and iOS. There's a great discussions in comments that also points how those things are different for the web because the differences apply. So your gradient with the very same spec or your text shadow will never look the same in your image-based design tool and then after production. Now, why this is important? It introduces a lot of tension between design and development. We probably all lived through situations when we were angry that after development, the product does not look exactly like we planned it in our design tool. This is all caused because of this mistake in the paradigm of design tools rooted back in the 80s. So it's a pretty old mistake, but it causes a lot of troubles on the web. Designers have less control over the final result because of that, and developers feel lost because they cannot recreate exactly what's coming out of those design tools. There's just a massive disconnect. Now, of course, when we are designing for any digital platform, we are designing interactive, dynamic experiences. But the tools that were meant to create images are not ready for this kind of environment, because in print, they didn't need to actually add any interactivity, or in editing photographs, they didn't need to add any interactivity. So this paradigm didn't have it from the start. Over the years, of course, different tool makers started to add a little bit of that here and there, but there are certain constraints on that. So the interactivity that we see today in the image-based design tool world is actually artboard-based. So we can hook up a couple of artboards. Some of these tools do better job than the others when it comes to animating elements across the artboards, but it's still dramatically limited. In particular, and when this is becoming very painful, it's when you cannot really create certain patterns which are key for the experience of users. So in any image-based design tool, you cannot create a real input that will allow user to enter some data and you will validate that data. It's impossible. You cannot design, let's say, a shopping cart where you would calculate the total of order after user selects a bunch of options in the prototype. You just can't do it. You cannot design a full sign-up flow that would allow users to go from the sign-up form, choose a password, and then use the same data to log into the application. You just cannot design it. You definitely cannot design a date picker that would allow you to test different dates, because the tools, image-based design tools, were originally meant to be static, so they don't support all of those use cases. Now, this is really the key to many problems in modern design, because our job as product designers, digital experience designer, is to control the reaction of users as much as we can, which means that we have to design certain experiences in order to have certain results on the user end. And to achieve this goal, we have to test prototypes early, test them often, test them in the cheapest way possible without involving our development forces, without building the actual thing before tests, because that just slows down the process. With image-based design tools, we just cannot do it. We can do some sort of a simplification of that process, but we'll never get information about the final experience. So this is a massive, massive problem. Now, another thing is that components are passive. And to really explain that problem, we have to dive a little bit deeper into the very nature of development today. So across all the most important platforms, across web and all the mobile platforms, development became highly modular. What does it mean? It means that developers are working with reusable components. Say React.js is a good example. You can divide, and you would divide any application into a certain number of components that you can quickly use in different parts of the product and different features. They're completely reusable in a very controlled way. Now, design tools kind of tries to keep the tempo of those changes, and introduced symbols in a bunch of those tools. Sometimes they're called components. But because of the static, passive nature of this paradigm of image-based design tools, those components do not carry any interactions. So they're not exactly reusable for designers because they are missing the key component of the experience. They represent the static thing. And if you think of it, it makes sense going back to the days of print. But for design of any interactive experiences, it actually introduces a lot of problems. So there are no states of elements that you can quickly create and refer back to and see them in action. And no saved interactions, so you cannot create, let's say, a table with sorting and save it as a component that you're going to reuse from now on across your organization. And those components cannot carry any logic. That's a drastic limitation of the capabilities of designers to actually use elements in their fullness across their products. And there are certain things that are better with symbols in this tool and the other tool. Like there's some progress, but the limitation is actually coming from this paradigm of the static image-based design. And finally, you could say the final nail in the coffin is the lack of connection to engineering. So we are always talking in the design industry that we want to be part of the conversation. We want to play a bigger role in software development. We want to be treated seriously. But to be part of any conversation, you have to speak the same language. And the language of digital experiences is code, whether we like it or not, because users are never going to see your sketch file, apart from icons or illustrations or photographs, of course. They're not going to see the file. They're not going to experience it. What they're going to experience is the code rendered by the technology in a given platform, right? By the web browser or an iPhone or an Android phone, which puts a certain pressure on code and makes it the source of truth. So whether gradient looks great in an image-based design tool, to use the simplest example, doesn't really matter to the user. What matters to the user is how it looks and behaves in code. And image-based design tools just don't touch code in any meaningful way. There's lack of single source of truth because they don't connect to the code repository in any way. They can't take something from the code repository and use it. And any attempts in the past couple of years to find this connection failed completely because of this difference in paradigm. Some things are just very, very hard to achieve, if not impossible. Image-based design tools basically force all of us designers to live in completely different constraints than when it comes to developers. We probably, all of us, experience that many times. Like sometimes a designer designs something only to learn that there is a component somewhere in the repository that developers can use, and then we have to face the dilemma, either we are spending time on building this new component or using the old component. Sometimes there are situations when designer designs some fancy animation using one of those tools that output video, shows that to developer, and it's very expensive or impossible to recreate, and there's supposed to be some easier choices. There are different constraints. And something that developers absolutely hate is that it's really hard to keep the image-based assets up to date, right? Decisions, changes during the development that happen in code are faster than updating 70 artboards with a change of something, a label or a button color or anything that is. But it is really an introduction of significant problems when you have assets out of date, and then another developer would start working on something based on your sketch file, and that's becoming, like a trouble for the entire team because nobody knows what's the true representation of the product that we're supposed to build. It's becoming very, very challenging. And of course, in the agile world, there's a great deal of conversations that's supposed to happen to keep this process dynamic and divide it into chunks. But even in the best implementation of agile, those things introduce problems and lack of connection between those two worlds that just cost us a lot of nerves and money. Now, representation of states, we kind of covered that. It's just very hard to draw all the static representations of every single stage if we're talking about something more complex than a landing page or just a dribble snapshot that you want to share with other designers. And whenever I hear about tools that output GIFs with animations, that's just not a great idea. I can't even stop GIF. Like, what developer is supposed to do with a GIF file? So significant challenges. And don't get me wrong, I mean, like, there's a lot of negativity perhaps coming on of this talk for the past couple of minutes. But the thing is that image-based design tools are still great, and they're getting better when it comes to their original use cases covered by the tools back in the 80s. So illustrations, icons, photo editing for some of them are still the ideal use cases for those tools. And those use cases are important parts of design in general. They're just not meant to actually serve the needs of the modern digital product design. And they were never meant to do that. And this paradigm is just holding those tools hostage. Okay, so let's talk about solution, code. And I'm not going to talk about whether designers should code or not, because there's not a clear answer to that question, and spending any time on that would be just a waste. I do think that the job of connecting designers to code, connecting designers to the truth of software development is a job of a design tool, which requires a different paradigm. So let me take a step back and tell you a couple of things about UXPin. I mean, like Lumi already introduced us. We are a code-based UX design platform. We are focused on 3 things, and we are always working on doing them the best in the world, collaborative prototyping design systems and simplifying documentation. But something that you haven't heard yet, and probably will explain a lot about what I'm going to show you, is our mission. So since the very beginning of the company, back in 2010, we are on the mission to merge, to connect design and development. This is our task. This is our job, to remove the constraints that actually limit the collaboration between designers and developers. And to achieve this goal, we had to do something dramatically different than other tools on the market. We knew that we can't build a tool that's going to be in the image-based design paradigm, because it's going to dramatically limit our ability to connect design to development. So we had to build a tool based on the different paradigm, code-based design. Now, what does it mean? In the image-based design tool paradigm, as you remember, the whole interaction between user and the software was that whenever something happens on the screen, user draws a rectangle, is getting built as a vector raster graphic. Now, in a code-based design tool, the whole flow is going to look identical. User just drags and draws something on the screen. But the key is what happens on the backend. On the backend, the code-based design tool actually builds HTML, CSS, and whenever interactions are added, the tool builds JavaScript. The user does not need to know HTML, CSS, and JavaScript, not at all. The tool is actually rendering the intent of the designer using those technologies. Now, that's actually introducing a lot of really massive opportunities. So first of all, the fidelity problem gets completely canceled, right? Because the code-based design tool is actually using the browser rendering engine to render the intent of the designer. So anything that is produced in the code-based design tool is going to look exactly the same after development, because it's the same text rendering engine, the same rendering engine for colors, the same technologies for gradients, shadows, and everything else. Now, because of this code-based design paradigm, the tool gets actually access to the full power of JavaScript. So the interactivity is not limited by anything but JavaScript. So that's opening up some amazing use cases I'm going to show you. And of course, this deep connection to the very nature of code gives us an opportunity to build a true bridge between design and development. And of course, that brings us to the true design systems that can be used as a single source of truth across the board in an organization. Okay, so now some examples. Some of the things that I'm going to show you are already in UXPin. You can play with it. Some of the things are coming up very, very soon. Okay, so first thing, we were talking about limitations on prototyping. So in a code-based design tool, those limitations do not exist. So let me show you an example. So this is something that I created last week for the launch of conditional interactions and variables that we broached to the market last week. And it's basically a very simple sign up form. You can see that I don't need to code anything. It's just all done through the interface. So sign up form, and there's a login form, and they're connected. Of course, there's a condition, like I'm checking the email, I'm checking the password. It's nothing really complex, but let's take a look at the flow that happens now. There are real inputs. Those are just HTML inputs. You can see that the label can disappear. I can show and hide password. I can change the type of the input. But now on the login form, UXPin actually remembers the data. You can validate the email. But the most important thing is that once you enter the correct email, correct password, you can check it, validate the password. And if it's correct, you can actually log in to the application. So you can simulate the entire flow. It feels natural, it feels like the final thing. So you can test it with users. It takes a couple of minutes to create something like that. Another example, very similar, that shows in a very attractive way how you can modify the experience based on user input is this screen of a pin-based interaction. So if the pin is not correct, then you cannot see the rest of the application. If it's correct, then you change the experience. And all of that is based on components. So those are not artboards that are linked together. Those are actual components that can be saved in a design system and reused across the experience. Okay, now something that we introduced last week, actually this week, data from JSON and Google Sheets. That's another an easy way for a code-based design tool, because we have access to all those technologies, It's much harder for an image-based design tool. So here I'm using match by layer data generator. So you can see that layers are named avatar, city, job title. Now if I'll just copy paste a bunch of them, select them, and update this data, I'm going to get the random selection of names and pictures across my design. You can connect your JSON source, you can connect your Google Sheet, and it will work exactly the same. Match layers by name and drop the right data into your prototype. Okay, now something that's coming up to UXPin. There is, of course, an ability to create advanced animations, but we are just about to introduce very soon new states of elements. So elements in UXPin can have states, and you can have your button with hover and active state and disabled state as a one component, and you can save it together with all the interactions into a design system. But let me show you what is possible so you can see how powerful can be a combination of CSS and JavaScript in animation. And it keeps things real. So this is not a video, this is not a GIF, this is not something that you would create with outside of the constraints of development. This is done with exactly the same technologies that developers are going to use. So you know that you can recreate it. And here's another example of a nice landing page. And you can take this carousel, for example, and save it as a component that you can reuse across your designs. You can also see that there's a little bit of course, of text, for photo editing in a code-based design tool as well. I mean, like whatever is possible in the browser is possible in a code-based design tool. And final example for animation, a mobile app with nice combination of components that introduce a lot of interactivity. Okay. Last thing before I'll do a cool demo, next level interaction. So here's something that's also coming up very soon, most likely next week. So I spent about 25 minutes working on this little prototype, a bunch of JavaScript expressions inside. And I created a fully functional calculator inside of UXPin. And you would probably think, calculator, that's crazy. I mean, like there are few people working on prototypes of calculators. But the thing is that the very same logic will apply to the shopping cart or any calculations of, I don't know, user management, right? When you need to actually add prices, add numbers, or do any sort of operations. So this pattern it's very complex, of course, but it has application across different prototypes, different experiences that we designers have to design every day. Image-based design tools, of course, cannot bring anything like it to the market. So this is coming up. Okay, so is that all? Of course, it's not all. So let me show you something that we've been working on for the past really 18 months, and it's called UXPin Merge. And now I'm going to switch off my presentation and show you something that you don't have access yet. This is the technologies in a private alpha. So Merge is an import of production code to the design editor, an import with 100% fidelity, of course, all the interactions coming from the repository. So you can imagine a use case where you just connect UXPin to the production code repository. For now, it works with React.js. And then momentarily, as a designer, you get access to components that already exist across your company, so you can use them in your design. Now, that brings quite amazing powers, the full power of code to designers, and you don't have to know how to code. So this thing here is a sample from Atlassian Atlas Kit. Let me just show you how it works. With first a simple component that is absolutely impossible to create in an image-based design tool, date picker. So first of all, this is one of the version of interface which shows JSX from React component, but you can also just use the classic form-like interface if JSX is not your thing. Now this is not something that was created originally in UXPin. It actually comes from the code file. Right, so this little React.js component takes the Atlas Kit React component, has the props, that's it. This thing landed in UXPin, and you can see the props over here. Designers can edit this component within the constraints set up in code, so exactly the same constraints for designers and for developers. You can, for example, change these components to a date picker, time picker, or date time picker, right? You can add an icon, you can change the icon, you can make it disabled, you can make it open. But the most important thing is that once we go to UXPin Preview, which is a shareable collaborative link that you can share across the team, this thing actually works. So you can select time. It's coming from code. It's just render of a production code. If we click on that, you actually get the full calendar, and you can switch between months. And I love this example because can you imagine how many artboards would that take if you would have to recreate this data? And what if you are testing a banking application and you need the user to select someday in June? How are you going to do that? Or if you need to move towards the past and select the data. This is all coming from code, and it's real and available to the designer momentarily. But let's add some other components so we can see how this thing works. So we'll add the global navigation pattern coming from Atlas Kit. You can see that with navigation, for example, I can switch between products, right? So let's say that we are working on bid bucket thing, right? Now, so you can imagine the pagination pattern is also going to work. Let's increase the number of pages to 20. You can see that it changed here. And there's a cool component somewhere here called tag group. We'll add some more tags. Let's switch to layers, and you can see that those tags are nested. You can edit the content, of course. I'm just not going to waste time for that. So we have a bunch of components here so you can see it in action. We'll go to UXPin Preview, automatically updated, of course. And now you can see that those tags are animated in a beautiful way. The pagination works. Even things, just delete that, even things that are infinitely more complex, like Atlas Kit has an NPS component, also work and are available to designer. So let me show you the entire flow. Of course, I'll give it a 10. Leave a comment, choose your role, send. So if in your company, there's an NPS component that you want to use in many different products and exists in code, it can be used in UXPin. And this is dramatically different than what image-based design tools offer, because there's no connection between image-based design tool and code whatsoever. And again, like the thing from the 80s, they were just not meant to serve this kind of complex use cases, and are really something that designers need today. And to finalize this little demo, you switch to the different design system. This is Pinterest Gestalt. And I will show you something that is a really good representation of how different code-based design tool, even if the basic use cases of drag and dropping elements are exactly the same. So let's go to a pretty wide video. I think that will be enough just for the sake of the demo. And now I'm going to do a couple of things. So first of all, let's say that we don't need those controls. So we'll switch it to false. We'll turn it off. But let's say that we want to start playing it. And you can probably hear the sound of it as well. It plays an HD video inside of your prototyping tool. We'll switch to preview, it plays here as well. Okay, we'll turn it off. All right, so you can see that the image-based design tool is as easy to use as a code-based design tool is as easy to use as an image-based design tool, but it comes with the power that we designers working on digital experiences really need today. And all this power actually comes from code, but we don't ask you to know how to code. Again, you can use the interface that doesn't even show you any code. Not that this is really hard to use, but like there are options. And you get all this power because of a different paradigm that this tool is built upon, and it's a different paradigm than this 40 years old image-based design tool paradigm. Okay, let me get back to the presentation. You saw a lot of what UXPin offers, what UXPin is going to offer. Just to sum up, merge. Import of React.js components. There are going to be different technologies supported in the future as well. The code is production. You don't have to write this code. It probably exists already in your company. And you get these components with 100% fidelity, all the interactions, everything works as the final product. And you can quickly prototype experiences, test them with users. And by the way, you can do a mix of coded components and just normal UXPin work in one prototype. It's all universal. You don't have to know how to code, and all of a sudden you have access to this power that's absolutely impossible for any image-based design tool out there, whether that's Sketch, Figma Studio, whatever it is. All those tools are rooted in this old paradigm. Now, you probably are wondering, how can I get access to that? So we are in private alpha, very close to beta, and we are going to let in more users. So we are gradually letting people in. There's a landing page. Lumi can post a link. You can sign up for the updates about the technology, and pretty soon, in a couple of months, it's going to be available to the entire market. So it's coming up. Now, 2 charts to finish this presentation. For those of you who are curious about the technology, so UXPin basically connects to the GitHub repository, uses continuous integration server, and from now on, once you do this connection once, every single time there's an update to coded components, they're automatically updated in UXPin. Their design system is automatically rendered in the correct version. So you kind of connect UXPin once and you can forget about it. Your team is always going to be up to date with whatever is going on in the code base. And finally, the workflow. The workflow, which is dramatically different than what we know right now. So unlike the image-based design tool workflow, there is no separation between design and development. Those are becoming part of the very same story, because both are connected to the single source of truth, which is code, the truth about user experience, the thing that users actually experience, not some artificial files that used to be meant for print. So developers, of course, ship their code as always, but it lands automatically in UXPin and is accessible to designers even if they don't code. With that, designers and developers both can actually build extremely powerful prototypes without investing into the full development of the full product. Those can get user tested, and of course they should be user tested, and that should span a bunch of iterations, of course, until the product is perfect. And once the product is perfect, it's shipped right from the code base to users. And any changes of the code base kind of like close the loop, because again, if something changed in components in your design system, UXPin gets automatically updated, designers have access to the newest thing, and they can move forwards. So it's one unified software development process instead of separated, siloed design and development processes and handing assets that are not reusable across the process. Okay, with that, I want to thank you, and I'm looking forward to hear your questions. And I'm going to stop the screen share.
Thank you, Marcin. Yeah, so if anybody has any questions for Marcin, please use the Q&A section at the bottom of the screen, and we'll try to get through as many as we can. So first question is, what kind of approaches does CSS are supported by Merge?
That's a great question. So, Merge is really CSS agnostic. So it doesn't matter whether you're using a preprocessor like Sass or Less or Stylus, whether you're using just vanilla CSS, any CSS in JS libraries, that doesn't really matter. Because the thing is that what Merge does is really builds your code on its own and then ships to the code that was already built to UXPin. So we get the final thing just like the browser gets it. So no matter what you're using is going to work. I also saw a bunch of questions about React and different technologies. So as you can imagine, Merge from the paradigm perspective is universal. Because of the fact that we are using the browser rendering engine, we can technically render any production code inside of UXPin. We started with React because React is by far the most popular way to write JavaScript for design systems. So in this highly modular way. Around 70% of design systems out there, open source design systems, are actually built with React. Once we get a significant number of requests for other technologies, whether that's Vue.js or Angular, we are going to invest into those. And of course, we are always looking at at web components, and we are kind of trying to understand where this is all going and whether that's going to be a standard.
Thank you, Martin. I have a few folks here. They are wondering how can they be on the testing for Merge?
So the best way is to actually sign up on our landing page. And then we are going to, once we have an beta open, then we will be gradually sending invitations to everyone. Now, for those of you who are super eager, there's a way to become part of alpha. But first of all, you have to meet the requirements for alpha. So there's a bunch of them, which basically means that your React.js code needs to be up to the standards in Facebook documentation. We want to see ideally CSS that is locally scoped, so per component. And the most important alpha requirement is actually that we need to have access to your code. So if your design system is open source, then and it's React based, then most likely we can bring you to alpha. If it's not, then you better wait for beta, because then you are going to just do GitHub authorization. It's going to be much simpler. Now, if your design system is open source and it's React.js based and the code quality is good and approach to CSS is all modular, it's all locally scoped, a majority of that, then feel free to reach out to me, and I'm going to work directly with you on bringing you to alpha. You can just use Twitter at Martian Trader, and you can just talk to me. So.
Okay, thank you, Martin. Can you also go into the merge components? Are you able to change the styles on those?
Absolutely. So those are whatever developers can change, you can change. So let's say that you have a button, right? And the button was coded with 4 distinctive styles for success, default, error, and warning. That's a very classic example. In every design system, buttons have those 4 states. You can switch between those styles quickly. There's also going to be an ability to actually switch the entire themes if this is something that your code base currently serves. So, for example, CA Technologies is one of our customers. They're in alpha for Merge, and they have themes for different products. They have apparently over 80 different products served by their design system. There's going to be an ability to just switch between themes, so every single team working on a particular product can use the right set of styles. So basically, whatever developers can change, whatever they code it into the components, you can change inside of Merge. So if you want to have a button with any color, you can just code into the component that it will accept a hex string as a color definition, and then you can do whatever you want. So yes, you can modify styles.
So are those prototypes built in UXPin, are they production ready?
So no, so this is not the goal, and this is a great question actually. So UXPin primarily works with big organizations, right? We have tens of thousands of smaller users, of course, but we are always optimizing for our big customers as well. Now, if you think about those big customers, they have really massive code bases. If we would even attempt to build code that is production ready, that's supposed to be shipped right from UXPin to their servers, would actually put a high risk on our customers. The reason is that this code would be very hard to maintain, because if a human didn't write it and the human is asked to maintain it, it becomes an impossible task. So we don't see our job as a production tool for websites, for web applications, for any kind of software. Our job is really just to connect design and development, which means that we want to keep designers in development within the same constraints of technologies, so use the very same technologies that they use, and we want them to speak the same language and connect to a single source of truth. So this is where the job of UXPin for now ends, right? So the code is not it's not production ready because it's not meant to actually be used in development. Developers will do their thing in the best way possible for the long-term success of any product, way better than any software can do.
Is UXPin Git compatible, or is there any other form of version control?
Yes, so merge is going to connect to a Git repository, and for authorization purposes, the first integration that we are most likely going to do is going to be integration with GitHub. But from the technology perspective, nothing stops us from actually connecting to any Git client. So most likely Bitbucket and other clients are going to be served next. And if you think in terms of merge, I mean, like we are as Git ready as any text as any text file, because we are basically basing whatever you see in UXPin on the code components that are stored in some sort of a repository. So it's absolutely just part of this normal software development process.
Okay, Martin, you mentioned earlier about Angular. Are there any plans for going in that direction?
Yes, so Angular is probably the second library out there that we are hearing the most about. There's a couple of problems with Angular that probably our audience is aware of. So first of all, Angular between versions is a little bit unstable and not always backwards compatible, which makes the task of integrating it into something like merge very hard, because it won't have to be version specific. And the other thing that works very well in React and can of course work well in Angular is that modularity of code. React is more forcing this modularity on users and this standard for custom properties. And Angular makes it possible, but there's plenty of ways people can write it. So with React, we can just use the general standards for writing a React application. For Angular, most likely would have to do some sort of an enforcement on certain standards because there's just so many options. So Angular is definitely on our minds, and it's something that we plan for, but it's going to be a little bit of a different integration than React. Vue.js, for example, which is really picking up on the general market, is going to be much easier for us to integrate. It's very similar to React. But yeah, definitely we're thinking about Angular. And there's a way also, I mean, there's a tricky way to kind of use merge with any technology, because you can write wrappers with React and place your Angular code inside. And you can definitely do something like that, and it's going to work. It's just an extra step in the process. I don't know if this is a good idea.
Okay, we have time for a few more questions. I have a question here around interactions. So how will the interactions built using the UI work and the coded components? Will a designer be able to override a click event?
Yes, wow, what a great question. That's an awesome question. So we are actually just finalizing our work of that. So next week, our alpha users are going to have 2 ways of integrating with UXPin interactions. The first one is exactly what this participant mentioned. So basically, you get access to all the call events from the component. So if there's an on click, you can connect to the on click. If there's an on change for an input, you can connect to on change. And then you can basically connect a normal UXPin interaction directly to this call event from the component. So some use cases would be, let's say that there's an drop down and there's a custom event attached to this drop down that basically on open of the drop down, you want something to change in the interface. So just connect to this on open and just apply normal UXPin interaction to whatever other element on the screen you have. So that's the first thing. Final test is going to be available most likely tomorrow, but it's Friday, so probably Monday. And the other way to actually do it is to programmatically change props between elements. And this is just a lovely piece of technology. So in React.js, you've seen all these props, like for example, a change of a product in the global navigation from Atlaskit, Atlassian Atlaskit. So imagine that you could basically connect with another element of your prototype to this very component, and on click switch it, this whole navigation to, let's say, from Bitbucket to Jira, right? So it's all going to be possible from within the interactions, because there's going to be a new action in UXPin interactions. We have triggers and actions for those of you who are UXPin users. There's going to be an action change prop in a coded component. So a pretty robust implementation in the final steps. We've been testing it for the past 2 weeks, and it feels pretty magical that you can interact like that with coded components. Great question.
Awesome. And we'll end with that. Thank you everyone for joining. If we didn't get to your question, you can always email us, or you can always tweet Marcin. And the recording will be sent after we have ended everything via email. So thank you again for joining.
Thank you all.